fantastic personality. He considers himself a science nerd. So if you want to talk to him after his speech, he's a science nerd. And he's an avid road biker. In fact, just last weekend, he rode a 100-mile ride. So very healthy as well. We're very honored to have you here, James. Please join me in welcoming James Meigs of Popular Mechanics.
For 100 years, we've been showing people the future. So of course we couldn't wait to put our magazine on the iPad. The question is, how do you fit all of this into something the size of this? Go ahead and try it. As a lot of our friends at other magazines have discovered, it's not that easy, is it? Okay, knock it off. We're a DIY magazine. We decided to solve this problem for ourselves. We took all the words and images from our print edition that our own editors, designers, and programmers totally rebuilt every page specifically for the iPad. There, that's better. Swipe through a few pages. It's easy. Everything's readable, just like print. But we can do a lot more. Check out this slide ladder. You can select a story and share it with a friend. Or bookmark it with just a tap. And you can find the table of contents from anywhere in the app. Or use the page view to jump straight to the story you want. Easy as that. Hey guys. In the PM workshop, we're programming a lot of new tools to make our stories come to life. Let's say you want to build this cabinet. We use 3D modeling to let you see the project from every angle. Then you can play an animation to see how the parts go together. And unlike in print, we can include as many pictures as we need to show readers every step. Nice job, guys. Our art department is having a blast making their designs interactive. Here's a story we did on an airplane race in print, and here's what we can do with the exact same illustration on the iPad. The iPad liberates designers from the limitations of paper. We're doing things we've never done before. We can take one page and turn it into two with something we call layout painting. Or make a sidebar that fills a whole page. Or even fit lots of big photos onto one page like we do in our new product section. Can someone take this for me? Thanks, Emily. We launched our first iPad app over the summer, and we got some great reviews. Now we've gone monthly, and we're taking it to the next level. With our live news feed, our content is updated several times a day via Wi-Fi or 3G. And now, even the ads are in. Pretty cool, huh? People think creating digital content is all about technology, but it's really about creativity. At Popular Mechanics, we believe that if we can dream it, we can build it. That's the approach we took to our iPad app, and that's the approach our readers take to life. We love looking to the future. We'll see you there.
What some of us in the publishing industry are doing to reimagine how journalism can reach the consumer, and of course the iPad and the other coming tablets offer a fantastic platform for us to do that. Now, as Ali said, Popular Mechanics has been around for over 100 years. In that time, we've covered the growth of technology, everything from the Model T and the Wright brothers to some current things. And when I'm in that, I can't tell you more about your field than you guys already know. You spent the day in all kinds of fascinating panels on the very kinds of things we write about. So what I really want to do is go a little bit more into what does this mean? Where is it going? And we've always covered how technology affects the lives of consumers. What does it mean for our daily lives? How are we going to live in the future? So along the way, over the course of 100 years, we've made some pretty excellent predictions. Like, this is the kind of flying car I have in my driveway. How about any of you? And of course, when I flew in to Orange County this morning, I was thrilled to land on top of the tallest building in town. Although a few other things have been a little more on target. Here's a story we did back in 1950 about what the world would look like in the year 2000. And no, we're not eating food made from sawdust just yet, although we will be getting biofuel from sawdust pretty soon. But doing our shopping over the picture phone, I think we call that the internet. A computer in the basement, well, maybe not in the basement, but 2 or 3 or 4 other rooms Information superhighway, check. I see that they say, this was before I joined the magazine, obviously, the greatest social revolution since the automobile. Yeah, I think that's about right. And now, I've been with the magazine about 6 years, and the world of technology is more exciting, I think, than ever. And the things that are converging happening today are just almost impossible to keep up with. So we're still making predictions. Will we have hyper-efficient airliners in the future? I think so. Will we have 100-mile-per-gallon vehicles in the near term? It's going to be pretty hard, but we're working on it. And so what I really want to do tonight is obviously dive into areas that all of you are involved in, embedded design, ubiquitous computing, and look at how the trends are coming in. So many of you work in different areas of this, see how these things are coming together in a way that will reshape our lives. So the first question is, can we define ubiquitous computing? Some people would say the first ubiquitous computers are more or less current versions of smartphones. Other people would go back a little farther and look for the first generation of PCs. Okay, how many people had one of these? Okay. But I think the first networked ubiquitous computer was the ATM. The first one was introduced in 1969 at a chemical bank on Long Island. I think their ad said something like, on Monday morning our bank will open and never close again. And that's basically what happened. And Donald Wetzel, who more or less invented the ATM, he knew exactly what this meant. It wasn't just a better way to do banking. This was the first machine that was going to teach people how to interact with an intelligent device. And it's hard to remember now, but it was a real learning curve to get people comfortable with the machine actually handling your money. If you think about it, all the technologies we're talking about, they may seem to offer all kinds of benefits, but they have trade-offs too. Imagine there was a time when if you wanted your money, you'd walk into a bank and a person would look you in the eye, often greet you by name and say, how can I help you? The entire transaction was organized around your need and the way the questions that you had. In contrast, going and interacting with an ATM means you have to accept the menu and the paradigm that the machine imposes on you. We take it for granted now, but it was a challenge for some people. As recently as the mid to late 80s, I remember in New York, there were still banks advertising, well, at our bank, you can still talk to a real person. I remember looking at my wife and going, I don't want to talk to a real person. but for some people, it did. It was one of those early age divides that technology often imposes where people over a certain age don't really feel comfortable with it. Under a certain age, it's just second nature. But when people gave up the comfort, the flexibility in the exchange for the convenience and freedom of getting your money anywhere, and in some ways safety too. Glenn Dorena, technology editor, argues that one of the reasons street crime fell in the 80s and 90s is people were carrying less cash around. You didn't have to go to the bank and get out $500 if you're going away for the weekend. You knew that you had $50 in your pocket. You could always find an ATM and get a little more cash. So what started as a somewhat daunting learning process for some, working with an ATM, turned into something that at Disneyland they can use as sort of a visual punchline to something so easy, even a dog can do it. Although I'm told these are well-trained service animals. So it's a great example of the famous theory of network effects, where you have a device that's not very useful when it's there in small numbers, but when it rolls out in volume, becomes extremely useful. The classic example, of course, being the telephone. If you've got the only telephone in town, you don't have much benefit. If you're the last person without a telephone in town, you begin to pay real social and even economic costs for not getting on board with the network. And like most networks, these things tend to start a little bit slow and then ramp up extremely aggressively, and then taper off when the market is more or less saturated. But there's one thing that all of you, I think, have to bear in mind. When you build a network, when you build a channel to deliver something that people want, if you build it, we will fill it. There is no limit to the processing power and the bandwidth that American consumers will consume as they take advantage of the capabilities that are coming on. There's no ceiling to this. And one of the early things that when they started building interstates in the early days, they thought, well, we'll build these great highways in the city, we'll relieve all this traffic congestion because people will be able to get in and out of the city earlier, easier. And one of the things that urban planners realized by about the mid-60s was you build a really great highway and people move out of the city to the suburbs and the highways are more congested than ever because you've made it easier for people to do something. There are a lot of analogies of that in the digital world. So, but if you think about networks, we're going to get kind of cosmic here. The history of civilization is the history of building networks, from transportation networks, from trails, the Silk Road, roads, rail, air routes, physical networks, to communications networks, verbal, mail, telegraph, telephone, internet. And each new wave of connections it unleashes greater power to use knowledge and information in new ways. If you were a stockbroker in New York in 1850, you could probably make some money trading stocks that you knew about from your own circle, your own network of information. As soon as they put that transatlantic cable in to Europe, all of a sudden you can trade stocks in London and Paris and Berlin, and you can make a lot more money. Your knowledge became more powerful through the extension of networks. So today we're living in a time when networks that used to be fairly end-to-end, the cell phones, talking about their cell phones, email, and to some extent the World Wide Web, these are all converging in one device, in the smartphone. So we're seeing networks combined. It's sort of an obvious point, but when you stop and think about the implications of it, it becomes pretty profound. We're at the beginning of the age of networked networks. So, if you think about the power of a single network is pretty amazing. But when they talk to each other, the power is multiplied. When you can use your cell phone to find the cheapest airline ticket and tell your bank to pay for it all in just a couple of clicks when you're walking down the street, that's an unprecedented kind of power in the commercial realm. And we're seeing that all across a whole range of human activities. Another thing that's new is networks used to be primarily, at the end they would come down to one person talking to another. One person's at one end of the cell phone, another person's at the other end. But today, networks are increasingly, they're mesh and they're interconnected. Now the machines are talking to each other. Look at an ATM. That's an early example of this. Nobody at my bank needed to answer the phone when the bank, here in Orange County, when I went and got some cash this afternoon, nobody at that bank had to call New York and say, hey, is it okay to give this guy a couple $100? The machines work it out together. The machines are talking to each other. And increasingly, we're going to see machines communicating, accessing information, processing information, and then making decisions on our behalf. And this is what's new, and the power of bringing these networks together is part of what I want to look at tonight. Why is it all happening now? Well, mostly because of the work that people like all of you in this room are doing. I don't need to lecture you on Moore's Law or the amazing work companies like Renesas are doing in bringing down processing power. The rise in connectivity, I think that the impact of 4G is going to be surpass almost anyone's imagination. When we all live in a mobile hotspot all the time, I think the implications of that are pretty profound. The increases in battery power, and actually even more important, the increase in power-efficient processors that help us get a little more mileage out of our batteries, so we can embed intelligence in everything. Standards are important, and some progress has been made there. And let's not forget sensors, because a lot of this new world of networks, of machines talking to machines, they're not just talking about information that humans generate. They're talking about information that the environment generates, temperature, how an engine's performing. There's so many kinds of data out there that networks are finding valuable in order to do other things. So the sensors that are feeding an unprecedented amount of data in these networks are a big part of the picture. So over 6 years at Popular Mechanics, we've covered, we've seen a lot of these things kind of develop and covered them along the way. Here's a story we did kind of early on about GPS and some of the promise of geolocation, which today seems kind of obvious, but 6 years ago wasn't quite as obvious. People thought GPS was just to help you, find the restaurant you're looking for. Another thing that's driving this increase is massive consumer demand for content that they create, that they consume, that they want to share, and the power of professional tools reaching the hands of consumers. I started my career covering the professional video industry. Well, today, everybody has access to high-def filmmaking equipment that would have blown the mind of the finest filmmakers in 1990. The continuing push on the part of the professional entertainment industry to drive technology forward, for example, with 3D. If you want to see an inflection point, or not really an inflection point, but a moment of where half of America is going to want to go to the store and overhaul their home entertainment systems, look for the month that Avatar is finally released on Blu-ray 3D. And you will see a major shift in consumer expectations from the new era. And just the amazing processing power of the technology we all carry around with us, from netbooks to iPads to phones, which continues to drive forward. New forms of interfaces. At Automotive Mechanics, we do this thing called the Breakthrough Awards every year. And a couple of years ago, we gave the award to most people probably know about Jeff Hahn's work, one of the real pioneers in multi-touch computing, gestural interfaces, and the better, more intuitive interfaces are a big part of this picture. So I want to look at the impact of these trends of networks, of machines talking to machines, in some of the areas where it affects our readers, it affects ordinary consumers, the people that ultimately are going to be buying the products that you guys develop. So, you've been sitting through panels on some of these issues, so I can learn more from you than you'd probably learn from me. But we all are looking for that day of the networked home, and we're really not that close to it yet. We have some kind of cool stuff, this Schlage system that connects their home security to the web, and you can unlock your car doors and get a notification pushed to you if somebody's in your house. That shows you the beginning of where things could be going. We've got progress in adoption of standards with Zigbee in particular. We've got a GE with some embedded intelligence in some of their new products, but we don't have everything talking to everything else really the way we need it yet. And as I said with the AGM, every new technology requires a certain trade-off. So, how many people have heated up cabinets under the wood stove? So you know that as long as you go out and split the wood, you can control the temperature in that cabin. You can make it as hot as you want just by sticking wood in the stove. You have direct hands-on control of that device. The minute the thermostat was invented, we actually gave up that direct control. We're leaving the decision of when to turn on the furnace to a device, actually a really kind of elegantly simple device. It's both a sensor and a switch, if you think about it. But you're letting the machine decide for you when the furnace goes on. Obviously, very few of us want to go back to wood stoves, but it's the beginning of that progress towards giving up some direct control, letting machines, I don't want to say run our lives, but manage our lives on our behalf. And when we start doing this, we also see a pretty characteristic curve in complexity. So, a classic thermostat is kind of brilliantly simple. At Automotive Mechanics, for years, we've been telling people to buy programmable thermostats, which are great, but a lot of consumers find them a little intimidating. The functionality sometimes is buried in a number of menus and sub-menus. Not everybody actually uses them. They install them, and they don't actually get the most out of them. Now we're starting to see the beginnings of another way of networked thermostats that begin to solve some of these problems, begin to both offer more functionality, but with an easier user interface. I was talking to somebody from, let me move to the next slide. So there's a lesson for all of you, which is that the developers who solve the problem of complexity, who make the technology transparent and easy for consumers, they're the ones who tend to dominate markets. Now, it's almost a cliche to bring up Apple at this point, but they've done this again and again and again. The Kindle also is a pretty good example of a technology that simplified something that had been around for years, the idea of reading books on a device, but they simplified the transaction part of it, so it's easy to buy them. And that's what blew open this whole category of e-readers. I was talking to somebody from Facebook the other day, and she said, you're talking about all the pushback they're getting on their privacy settings. she said that, well, yeah, how complicated they are. She said, well, consumers really want simplicity, but they also want granularity. And that's a challenge that you will all be involved with in the coming years, is making things simple on the surface, but giving consumers a way to dig down to the granularity they want underneath. And there are no easy ways to do this. One thing that we're looking at in home that's kind of neat, another product that won one of our breakthrough awards is Microsoft Xbox Connect. For those who haven't fiddled around with it, it's a video gaming system. It's kind of like, imagine a Wii system where you don't need the device in your hand. You just wave your hand and the camera on the device recognizes you. In fact, you can create an avatar of you. But you can use this to control a lot of other things. You can use it as a TV remote if there's something on you don't want. You can change the channel just like you're swiping the page on an iPad. And they're even working on a variety of experiments with various interfaces that allow people to interact with their house, talk to the house. Well, imagine you have this in every room, and as you go through the house is watching you and trying to assess what it is that you want. It's both kind of cool and kind of creepy at the same time. So, now you guys have been on panels on this. We don't need to walk through all the different ways that houses will be networked, but clearly, when all the appliances are networked and can talk to each other, when everything is connected to a smart grid, when manufacturers can monitor the performance of the product in your house and push updates and maintenance information down to the product, life gets a lot simpler and a lot more efficient. But as in everything that we're looking at, there's control that you gain, and there's also certain things that you lose. Clearly, the environmental benefit of smart products and connected smart grid is enormous. The home security and peace of mind elements are very real, but there's also a sense of, my home is my castle. If there's cameras all over and the power company's connected and the appliance company's connected, is it somebody watching me somehow? There's a great deal of kind of vague concern about this on the part of the American public. That's another issue that designers are going to have to grapple with, is creating all these capabilities, but also addressing some of the insecurities people have when the walls of their house are no longer permeable to information. No longer impermeable to information. Information will flow out of your house, out of the environment, in all different directions. And are you comfortable with that? So one of the areas that I also want to look at is the automobile, an obsession of the American public in popular mechanics for many years. And I'll walk you through the evolution of an interface. Okay, this is a 1966 Ford Galaxy. My first car was a 1968 Ford Galaxy I inherited in its declining years from my grandmother. It had about 8 buttons on the control panel. The radio was 2 knobs and 5 buttons. The heater was 2 levers and a multi-pole switch. And the air conditioning system was great. It was actually a rotary crank on the door, and when you turn it, it rolled the window down. Some of you may have seen this technology. But you can operate every one of these controls in the dark without ever taking your eyes off the road. Here's the interior of a 2011 M-Class Infiniti, beautiful car, and a very sophisticated interface. Roughly 60 individual buttons, plus 2 scroll wheels that control nav screen menus, sub-menus, sub-menus, all of which have to be visually verified while you're driving in order to control the vehicle. So we're seeing that arc from simple to greater capability and more complexity. Has anybody come up with a simple interface? No. Again and again, we see the auto car makers coming up with their imagination of what it's going to look like in these various, these various cars that they show at car shows. But no one's really modeled this. The company that figures this out will have enormous influence in the market of the future. And so let me go back for 1 second. I got sort of a question for people. How many people saw the news about the Google's autonomous car that's been driving around the Bay Area? Basically, a car that drives itself, supervised for now by an adult, supposedly. So, okay, how many people would like to have an autonomous car that can could drive itself, and you can just sit back and do the paper. Okay? How many people would say, hell no, I'm the human being, I want to drive? Okay, well I got a little bit of news for the latter category. Your car already drives for you. Unless you are driving something like that 68 Galaxy, your car will, anti-lock brakes will come on if your car decides you're not braking effectively enough. If you drive into a curve too fast, it doesn't matter how hard you're pushing down on the accelerator, the car will cut the throttle and start applying brakes to prevent a skid or a rollover. The car takes over from you when it doesn't think you're doing a good job. And we're seeing a whole host of innovations in safety and other things that are getting us closer to that autonomous car. Adaptive cruise control that controls the distance between other cars. Pedestrian awareness systems will brake the car if it thinks you're going to hit a pedestrian. And on the other end, on what's called the sort of infotainment or telematic system, we're seeing more integration of all these technologies coming together in the car. In some ways, the car may be the most networked place in our lives within the next few years. And don't forget, you've also got an engine computer that's generating tons of data, and more people are plugging into that and monitoring that in real time. We just gave an award to an iPad app that will let you basically turn your iPad into a scan tool. So you guys know the implications of all this: cars that talk to infrastructure, cars that talk to each other. A lot of wonderful things are going to come out of this, especially in energy efficiency. But we do lose things and we gain things. We gain a lot of safety, we save a lot of energy, but that sense of the open road, the person behind the wheel is something we lose. As people spend more time having the car observe and make decisions with them, do we lose some skill in driving? Something they worry about a lot in the aviation field, where planes spend so much time on autopilot that in an emergency when the plane goes off autopilot, is that pilot's skills are they going to be too rusty for him to take over that aircraft in an emergency situation? And anything that's networked can be hacked. And we recently worked on a story where we worked with a team that's demonstrated a number of different ways to hack a car, where they can turn your car on and off, turn the lights on and off, shut down the car while it's running, or break individual wheels while the car is going in order to put it into a skid. Not a huge threat to any of us, but it's technically possible. Final thing I want to look at is the whole wide world, what all this technology means when we go out into the world. So we've talked about all these different networks that are talking to other networks. Well, now we're seeing those networks also becoming an overlay on the physical networks of roads, businesses, stores, the physical world that we walk through. I'm sure you guys have talked a lot today about geolocation and location-based marketing. That stuff's here now, but it's not a seamless web yet. But here's an example. This is my favorite iPad app. One of the fun things I get to do with Power Mechanics, we get to test drive all these cars. So I got to drive across the country in a Nissan 370Z a couple of months ago, and I found that this app called Trapster is the most valuable thing on my trip. It's basically a community of people who report every speed trap they see. So the app builds up a library of warnings of where likely speed traps are, where active speed traps have been seen, and it'll give you a little beep. This shows you the area around my office in Manhattan, where there probably aren't a lot of speed traps, but a lot of times I've been in meetings, all of a sudden little thing starts pinging and it's reporting some speed trap, even though I'm sitting in a conference room in Manhattan. But think about it. So you talk about networks. So here's a 3G network connecting to a social network to help prevent me from getting a ticket on a concrete network of roads. So in the future, we're all going to be like Arnold Schwarzenegger in the Terminator. We're going to be able to walk around and look at things, and all the data about what they are is going to pop up if we want it. And wherever we walk, anybody wants to sell us anything knows we're coming and starts giving us offers for if the system knows we haven't eaten since 6 a.m., offers for $1 off on a subway or something like that. So the world we live in is going to be incredibly rich with information. It's going to be hyper efficient in terms of commerce. We'll be able to augment our memories with all kinds of additional information. Crowdsourced data collection, that Trapster app is just the most primitive example of how this will change our lives. But what do we give up? You emit a ton of data right now that goes out in the world in various ways with credit cards and everything else. imagine the cloud of data that you're going to be emanating in this kind of world. How do you control it? Who has access to it? There's genuine consumer anxiety about this. Some breakdown of the social glue. You know, my community of people on Tramster isn't quite like my community of neighbors across the street. Can we cope with the constant flood of information? And does it actually change our minds after a while to have so much information that we don't have to remember because we've got it stored somewhere? How many people remember their phone number when they were growing up? How many remember your mother's cell phone number? She's had that number a long time, hasn't she? So, you know, we don't have to remember as much anymore. That's probably a good thing, but it's a change. And we're going to be wrestling with these changes in the coming decades. The most popular mechanics cover of the last 3 years. So you guys are in the business in a way of you don't see this traffic, but you're creating technologies that allow people to be linked to networks. There's deep anxiety about this stuff. And you saw the uproar over Toyota's, I think, fairly bogus claims of unintended acceleration. People don't understand the machine. They're afraid of the machine. They think the machine is doing something intentionally to hurt them. It's silly. Anybody who understands technology knows it's silly. But those feelings are out there, and we all have to grapple, both in terms of education, but also in terms of design and thinking about ways to protect privacy and encrypt data. So what's next? There's one more network. There's one more interface that we haven't addressed, and that's the human interface. There's a woman named Barbara Campbell in that photo there who was also at a Breakthrough Awards last week. She is one of the first human beings to receive a retinal implant that takes information from a camera in her, she's profoundly blind, has been since a teenager, takes information from a little camera in her glasses, feeds it into a chip that then directly stimulates neurons in her retina to create sight. It's a digital neural interface. I mean, a cochlear implant, to some extent, does the same thing. We're going to be seeing a lot more of this. And right now it's very primitive, but in a couple of years it'll be advanced enough that she'll be able to recognize faces and read large font type. There have been a number of prostheses in recent years that, again, this is one that has a direct neural interface. So when your brain says squeeze your hand, the hand will close and it'll actually send signals of sensation back into your nervous system. So the nervous system is interacting with the digital device. And here's a guy named John Donahue, another former Breakthrough winner, who also was a pioneer in neural interfaces in prosthetics. Now he's moving to the next stage, which is something he calls brain gate, direct neural interface with the human brain. Right now, primarily oriented around profoundly disabled people like with ALS and stuff who really can't communicate. But there's no reason this technology couldn't eventually be used to augment our capabilities, to link us directly to these vast networks of data we're creating. So if that isn't kind of mind-blowing enough for you, then I think I'm talking to the wrong audience, because to me it's really profound. It's scary, but also holds enormous promise as well. So back at the Quantum Mechanics Mad Scientist Lab, we will be watching these trends, watching the work that all of you do, trying to figure out where it's all going, and trying to make a few predictions that we hope will hold up in 50 years. So thank you very much.
That stuff is cool. And most of you guys are going to design it. Thank you very much, Jen. Very insightful. I can tell you from our side, the Renesas side, we have thoroughly enjoyed having you here for these past 2 days. It's been a great experience for us. We really appreciate your presence. We hope that you'll come back. We'll have another Devcon in 2 years. And we hope that we have addressed and can continue to address your innovation challenges when you return. Tomorrow morning, breakfast starts at 7. The bars are still open. Please help yourself. Let's network, let's socialize, and have a great time. Thank you very much.
got a pretty cool job.